In this video, we'll solve the functional equation f of x plus f of y equals f of x times y. So we're going to solve for f of x or f of y, it doesn't really matter. So we're going to take the derivative on both sides with respect to x, but the partial derivative. So this will be the partial derivative with respect to x, which is just f prime of x. F of y, the derivative with respect to x with partial rise will go to 0. This will be equal to the partial derivative with respect to x of f of x times y. So we're basically, you treat that y as a constant, so you bring the constant to the front, because that's the derivative of the inside with respect to x, times the derivative of f evaluated at xy. This is equal to f prime of x. So you could plug in y equals 1, but that just gives you f prime of x equals 1 times f prime of x, and that's not helpful. So let's plug in x equals 1 and see what we get. So we get f prime of 1 equals y times f prime. 1 times y is just y. But look right here, we have, on the right hand side, we have f prime of y. So let's divide by y. So we get f prime of y equals f prime of 1 over y. To get f of x or f of y, we're going to integrate both sides with respect to y. So now we get f of y. I'm going to put the constant on the right hand side. So this will be f prime of 1 times the integral of 1 over y is log of y. You could do absolute value, but I'm just going to ignore it for now. And then plus, let's call the constant k. But we like f of x, so it'd be in terms of x instead of y. So this would be f of x, be f prime of 1 is just a constant, so I'll just call it c1 log of x plus c2 will be k. So this is not totally it, but we'll see when we plug this in to the original equation what happens to c1 and c2. So let's plug that in. So that'll be c1 log x plus c2, then parentheses, plus c1 log y plus c2. Now this all equals c1. Now we have log, we're plugging in xy for x, plus c2. And c1 log x and c1 log y can combine to be c1 times log x plus log y. But again, using this, we get log xy. So we get c1 log xy plus 2c2 equals c1 log xy plus c2. Obviously, these cancel. c2 cancels, so this 2 turns into a 1, and the right-hand side is equal to 0. So we find out quickly that c2 is equal to 0. That means our solution is f of x is equal to c1 times, or I can just call it c times log of x. And that is the end of the video. Hope you liked it.